This video documents the step-by-step design and building of my electric scooter folding handle using CAD-CAM and CNC technology. The folding handle assembly consists of three main components, which are the handle mount, the quick release, and the base. The presentation will focus on the base. I plan to cover the other two components with follow-up videos. This is a continuation of my previous video where I covered the design and build of the entire scooter. Check it out in case you haven't yet. The projects on this channel will highlight the interconnectedness of product design and manufacturing. I will focus on how CAD-CAM and CNC technologies can be used to achieve this. If you like to create, design, machine and build interesting stuff, buckle up and get ready for the ride. As I begin the design process, it is also critical to think about how the part will be manufactured. How will the workpiece be clamped onto the work table? What material stock size will be used? That introduces the principles of DFM, or design for manufacturing. For example, this particular part is deliberately designed to be made out of 1-inch thick aluminum standard rectangular stock. Because this stock is readily available, it is also cost effective. Also, my part is 1-inch thick. The stock is also 1-inch thick. That eliminates an entire extra operation. The 1-inch stock is represented by the first CAD model feature. I then add the 257 diameter holes, which are clearance holes for the 1/4 screws, and can be easily achieved by using standard F drills, which is another DFM principle of using standard tooling. I now go ahead and remove the extra material using a standard 1/2-inch end mill. Adding the radii to the inner corners. Why are the radii important to the inner corners? Why not just leave sharp turns? Well, hint, this is another DFM principle, and go down to the comments and let me know. I now add the counterbolt, which will house the machine screw heads, using a standard counterbolt followed by the chamfer tool. The rest of the features will be achieved in the second setup, where the part is clamped sideways. If you're liking this type of detail so far, smash that like button, subscribe, and also mention that in the comment section so that YouTube will share the videos even more. Once the 3D models are completed, I now begin the machining strategy and develop the program. My machine has a Stevens plate, so I know I can clamp the workpiece as shown. I will begin by first machining the inside features moving outwards. I'll first drill in the 4 screw clearance holes using the 257 standard drill. Rough out all the internal cavities using the 1/2-inch standard end mill. Counterbores, chamfers, then cut out the part profile, exposing the tabs that prevent the part from flying out. The machining sequence is critical and needs to be planned out. The rest of the features are achieved by mounting the workpiece on its side on a second setup. Once the program is completed, the G-codes are then loaded into the machine. The workpiece is fixated. The 3 dowel pins are used to square out the workpiece before the hold-down clamps are added as shown. I begin with the spot drilling, followed by the 257 drills to create the clearance holes. The 1/2-inch end mill will now rough out all the cavities. Followed by the chamfer mill and the counterbolt. I now cut out the part profile, exposing the tabs that prevent the part from flying away. followed by the tab cuddle and belting before fiber wheeling to completion. The part is now set up on its side and machined to completion as shown. The parts are now assembled together using a 1/4 machine screws to reveal the folding handle. Let me know in the comments if you like this kind of detail going forward, or if you need any clarification. Watch out for the next videos featuring the mount and the quick release component detailed. Don't forget to smash that like button and to subscribe and share.